Hey kiddos, hope y'all are having a great day. Today we are going to move on to our next learning target. I've lost my pen. Oh, here it is. Our next learning target is I can simplify binomial radical expressions. And I know it kind of probably sounds scary, but we'll get through it, I promise. So binomial, that word means two terms. Radical, we've been dealing with, the square roots, cube roots, things like that. And expression, you should know what that means, but I don't think I've ever actually defined it. So an expression is like x plus 2. That's an expression because it doesn't have an equal sign. It becomes an equation when an equal sign is involved. So we're just dealing with expressions. So I can simplify binomial radical expressions. So we will do binomial expressions is what we'll title our notes today. And just for reference, binomial, that means two terms. So essentially what we're dealing with is we're dealing with the distributive property and foiling today. So it's a skill that you already have, and it's been in your toolbox forever. We're just bringing it back out and adding a little bit to it with the radical situation. So for instance, our first example is if we have 3 plus radical 5 times 1 plus radical 5. So when we're dealing with these, since we are multiplying radicals, we're going to have to check for indexes for multiplication. Yes, they both have the same index, so we're good there. And then we just have to remember our quote-unquote foiling method, which is a way to remember how to do this. It doesn't really matter what order you do it in as long as you multiply all the correct things that need to be multiplied. But foiling is the term that we often use, and foiling is first, outer, inner, last. So foil. First, outer, inner, last. If you've ever heard this term, this is what it stands for. So we're just going to start with distributing. So I'm going to go ahead and draw my arrows, do my first, my outer, my inner, and my last. So our first arrow is 3 times 1. 3 times 1 is going to give me 3. Then we're going to do 3 times radical 5. So that's going to be plus 3 radical 5. And then we're going to have radical 5 times 1. So that's going to be plus radical. That's a horrible radical sign, radical 5. And then radical 5 times radical 5. So we have to bring back some of the stuff we did earlier. Remember, when you multiply two square roots that have the same radicand, you're just going to end up with what's inside. Plus 5. And then it's just the process of combining like terms. So my whole numbers, I have 5 and 3. And then stuff involving my radicals, I have these two. So 3 plus 5 is going to give me, let's not do an equal sign, let's do an arrow. That's going to give me 8. And then 3 radical 5 plus radical 5, that's going to give me 4 radical 5. So not too shabby. That's what we're working on today. So example number 2 is we're going to have 3 minus 4 radical 2 times 5 minus 6 radical 2. So again, we're going to do our multiplying. We're going to do 3 times negative 6 radical 2 is going to give me negative 18 radical 2. Oh, I missed one, sorry. And then we're going to do 3 times 5. See, it doesn't matter what order you go in as long as you make sure you multiply what's over here by both of these and what's over here by both of these. It's okay if you accidentally go in the wrong order. Then 3 times 5, that's going to give us 15. So plus 15 because it's positive. And then it's going to be negative 4 radical 2 times 5. It's going to give me negative 20 radical 2. And then negative 4 radical 2 times negative 6 radical 2. 2 negatives is going to give me a positive, so plus 24 radical 2. So now I'm ready to go ahead and combine like terms. So this is my lone whole number, and then these are my radical like terms. So we're going to have 15 plus negative 18 plus negative 20. That's going to give me negative 38. plus 24. Okay, I want to look back at my notes here over something. Oh, see, Miss Morgan doesn't follow her own notes. Let's backtrack here. -4 times -6 is going to give me that 24, but we can't forget to also multiply our radicals. So radical 2 times radical 2, that's going to give me a radical 4. And we know that radical 4, that's a perfect square, so that's just going to break down to 2. So this is going to give me 24 times 2, which is 48. So I'm actually going to have 2 whole numbers there, so get rid of that one. My apologies for that. So 15 plus 48 is going to give us 63. And then -18 plus -20 is going to give me -38 radical 2. So let me go through this again because I messed that up. 3 times -6 radical 2 is going to give me -8 radical 2. 3 times 5 is 15. -4 radical 2 times 5 is -20 radical 2. And then -4 radical 2 times -6 radical 2. You can't forget to multiply both what's on the outside and what's on the inside. Like I did. Don't be like me. Do as I say, not as I do. So -4 times -6 is going to give me that 24. Radical 2 times radical 2 gives me a 2, and those are being multiplied together, and that's how I get that 48. And then I'm going to go ahead and combine my like terms, and I end up with 63 minus 38 radical 2. All right, let's do this example. So 5 minus radical 11, and then 5 plus radical 11. All right, same process. So 5 times 5 is going to give me 25. 5 times radical 11 is going to give me 5 radical 11. -11 times 5 is going to give me, negative radical 11 times 5 is going to give me -5 radical 11. -11 plus, okay, you could do it that way. -11 plus let me start over here with the sentence. Negative radical 11 times radical 11. That's either going to give me -11 or it's going to give me negative radical 121, whichever rule you would like to follow, just multiplying on the inside. We can go ahead and see if we can simplify anything. We can simplify this 121 because that's a perfect square. That's going to turn us into that 11. And then we're going to see what like terms we can combine. So we have this 25, we have the -11, and then we have these two. So it's going to be 25 minus 11 is going to give me 14. And then 5 radical 11 minus 5 radical 11, those are going to cancel and give me 0. So this operation right here, this binomial radical expression, this is a special one, a special case. This is called, these two things are called conjugates. These two are called conjugates. So let me get another piece of paper. So this is an important vocabulary term. Conjugates essentially the way to think about it is they're the same, almost the same exact expression. The only difference is one has a plus sign and one has a minus sign. So you're going to have something such as 4 plus radical 6 and then 4 minus radical 6. This is an example of a conjugate because your first two terms are the same, your last terms are the same, and the only thing that differs is this here in the middle. So whenever you have conjugates, that means your answer is going to be a real number. So as we look back at our first examples that we did, like this one up here, 3 plus radical 5 times 1 plus radical 5. These are not conjugates because they're not the exact same, and one's not positive and one's not negative. This is just a normal expression. And when we work this out, we got a plus, and then we got an answer with a radical in it. But when you're dealing with conjugates, you're going to get an answer that is just a real number. So that is the important property of conjugates. So these come up a lot, and this is a very important term to know. So whenever you want to essentially, well, this will segue us into our next example. So sometimes you'll be given expressions such as 4 over, what example is this number? Example 4. 4 over 1 plus radical 3. So a few learning targets ago, we learned how to rationalize if we had stuff like 5 over radical 2. We would just multiply by radical 2, and then that would give us 5 radical 2 over 2, and we'd be done. Because what we're trying to do here is we're trying to get that whole number, or real number, on the bottom here. And we were able to do that by just multiplying by the denominator on both the top and the bottom. So here, if we were to multiply by, let's just go ahead and do it the same way we did it earlier. So we would multiply by the denominator, 1 plus radical 3, 1 plus radical 3. That's going to give us 4 plus 4 radical 3. And then we're going to go through our steps, and we're going to have 1 plus radical 3 plus radical 3 plus 3. And then that's going to give us 4 plus 4 radical 3 over 4 plus 2 radical 3. And we're still going to end up having this in the bottom here, this radical in this form. We don't want this. We just want to go ahead and get that into a simplest form whole number. So whenever we're rationalizing fractions that have binomial expressions on the bottom, we're not going to use the same rationalization method that we used prior. We're going to have to use conjugates. So conjugate is still going to be a fancy form of 1, like we talked about earlier. It's still going to be multiplying the same thing on the top and bottom, except it's not the same as the denominator. It's going to be the conjugate of the denominator. So we're going to have 4 over 1 plus radical 3, and we want to rationalize it. So we're going to multiply that by 1 minus radical 3 and 1 minus radical 3. So we'll go ahead, and 4 times 1 is going to give us 4. Remember, this has to go to everything. So 4 times negative radical 3 is going to give us minus 4 radical 3. And then we're going to do our bottom. 1 times 1 is 1. 1 times negative radical 3 is going to give us negative radical 3. And then we're going to have plus radical 3. And then we're going to have minus 3. Okay, so the thing you're looking for with conjugates is you're looking for your radicals to cancel out. So you're going to have one that's negative, one that's positive, and that's going to give us 0 and essentially cancel out. And then we're going to be left with, we'll be left with 4 minus 4 radical 3 over 1, this goes away, 1 minus 3, which is going to give us negative 2. And then we can take that one step further, go ahead and divide that negative 2. So we'll be left with negative 2, negative 2, we have 2 negatives, we'll make a positive, plus radical 3. So I'm making sure I did this right. Something doesn't look right up there. But yeah, it doesn't matter. This was just to show you what not to do. Do not multiply by the same exact thing. You have to remember when you're dealing with binomials in the denominator, you have to use the conjugate. The conjugate, remember, is the opposite, essentially. You're just changing that plus sign to a minus sign, or that minus sign to a plus sign. So let's do another example like that. This is especially, I see this on the ACT all the time. So if we have 3 over 3 plus radical 6. I'm making this example up on the top of my head, so we're going to hope it works out. So we want to rationalize this, so we're going to have to multiply by the conjugate. So that's going to be 3 minus radical 6, 3 minus radical 6. We'll go ahead and multiply the top first. So that's going to give me 3 times 3 is 9, minus 3 radical 6. Then we're going to have 3 times 3 is 9. 3 times negative radical 6 is going to give me negative 3 radical 6. It's going to give me positive 3 radical 6. And then radical 6 times negative radical 6, that's going to give me negative 6. So I can go ahead and simplify some stuff. These two are going to cancel out because they add to be 0. I'm going to be left with 9 minus 3 radical 6 over 9 minus 6 is going to give me 3. And so we see how our denominator is a whole number. That's what we're looking for. But for this one, not all of them, but for this one, we are able to simplify one step further, able to do 9 divided by 3, which is going to give me 3 minus 3 radical 6. So the tricky thing for this is we struggle a lot of the time when we're doing stuff like this. We often multiply wrong or we forget to multiply something. So make sure you're drawing your arrows, or if arrows don't work for you, you're underlining whatever it is that you do to get it straight. Make sure you're doing that to make sure everything gets multiplied and combined correctly like it's supposed to be. And then just make sure you take your time and remember to do the conjugate when you're dealing with your fractions. There'll be 5 of those on your Delta Math assignment, and there's just going to be, I believe, 10 regular, like our first couple examples, just kind of multiplying like this. Make sure you take that extra step and are simplifying to as far as you can simplify. As always, if you have questions, please make sure you're asking, and make sure you're keeping up with your notes, all that jazz. Be productive, have a great day, and I'll see you when I see you.